Welcome to this screencast where we will discuss more examples of truth tables. In a previous screencast we looked at the truth tables for some of the basic logical operators that we have learned, such as conjunction, disjunction, and negation. In this screencast we will look at some more complicated examples. In this example, let's consider the conjunction P and not P. We begin with only one statement, so there are only two possible cases to consider: when P is true and when P is false. Of course, not P has the opposite truth values of P. Now, for P and not P to be true, we just need P to be true and not P to be true. Of course, since P and not P have opposite truth values, this can never happen, and both cases give us a truth value of false. In this case, we see that the truth values are always false no matter what. And this is an example of a contradiction, a compound statement that is always false. Now let's look at the truth tables for a more complicated compound statement. In this example, we will complete the truth table for not P and Q, or P. Instead of trying to figure out the truth values of the statement all at once, it's sometimes a good idea to break it up into smaller pieces and determine the truth values of the individual compound statements that make up the whole statement and keep track of them within one truth table. For example, we might want to write the truth values of P and Q first, then we can include the negation of that, and then we can combine it with the disjunction, or P, to get the truth value of the entire statement. We've already determined the truth values of the conjunction P and Q. It's true in the first case, and it's false everywhere else. Now, it would be really easy to fill in the rest of this. Of course, the negation of P and Q has the opposite truth values, so it would be false in the first entry, and then true everywhere else. It's just the opposite truth values of the column previous to it. Now, when we combine this with the disjunction, or P, remember we need not P and Q to be true, or we need P to be true, or both of them. So to do this, we first notice that P is true in the first entry, so this will be a true truth value in that first entry. In the next row, both P and the negation of P and Q are true, so we get true here. And similarly, as we go through the table, P is false in both of these, but the negation of P and Q is true. So we will get a true truth value in both of those entries as well. Similar to the previous example, we are now getting the same truth value in all possible cases. In this case, we're getting true in all of them. This is an example of something called a tautology. It's a compound statement that is always true. In this last example, we complete the truth table for P or not Q and R. Because there are three statements P, Q, and R, we add a column for the statement R, and this gives us a total of 8 different truth combinations, as illustrated in the first 3 columns. To complete this truth table, let's first look at the disjunction P or not Q, and then we will combine it with the conjunction R in the last column. Getting the truth values for P or not Q is really easy. We either need P to be true or we need not Q to be true. Well, P is true in the first 4 rows, so we can go ahead and just complete those first 4 rows very easily by just knowing that P is true. For the remaining 4 rows, P is false. So to get these truth values, we need to look at not Q. Not Q is the opposite of Q. So since Q is true in the next 2 rows, not Q is false. And we therefore get that neither P nor not Q are true. And so it will be false in these 2 cases. In the next 2 rows, Q is false. Therefore not Q is true, and the disjunction gives us back true truth values in those last 2 rows. Now, to complete the truth values for the overall statement in the last column, we just take the column we just completed, it must be true, and R must be true. Well, the previous column already has a false in 2 of these locations, and therefore the conjunction cannot be true in those cases. So let me go ahead and complete that part of the table by looking at P or not Q. Now, P or not Q is true in all the remaining places, and the truth value will just depend on R. In this first row, R is true, therefore the conjunction is true. In the next one it's false, so the conjunction is false. In the next row, R is true, so the conjunction must be true. And then, in the next one, R is false, so the conjunction must be false. We've already got the next two rows, so let's skip down to the last two rows. When R is true, so is the conjunction. And in the last row, R is false, so is the conjunction. And we have now completed the truth table for this more complicated compound statement. The last thing that I want to point out here is the ordering of all of these rows. In future screencasts, we're going to want to compare truth values and compare truth tables of various statements. And so it's important that you have the ordering correct. In all truth tables that we complete using three statements, P, Q, and R, we will try to use the same ordering throughout them for consistency. Please notice that the first column, the truth values for P, we have 4 trues, and then we have 4 false statements. And then in the Q column, they alternate by 2's. We have 2 trues, 2 falses, and then 2 trues and 2 falses again. And then in the column R, they just alternate true, false, and so on. We'll again try to use this ordering in all screencasts to follow.